Well, hello, and welcome back. I'm AJ O'Neill, and I will be your Beyond Code Live instructor for the evening. Tonight's session is on more programmer jargon and alphabet soup. And the reason for this is because I'm working on some other material for the week that needs a bit more preparation before we dig into it. And I wanted to pick something quick and easy for tonight that we can just go through, have a little bit of fun, and still be productive. So, and if at any point during the video you find this helpful or useful, please go ahead and give it a big fat thumbs up. And let me see if there's anything else here I need to read off as part of my intro. I'm so bad at this stuff. But yeah. Like, subscribe, ring the bell. No, that comes afterwards. Yeah, and comment and comment with a time code if there's anything that you want to share with other people. That's always nice to have the time code in there. Okay, so we're going to start off. We left off with integrated development platform. I think we touched on what that is. Basically, something like Vim or VS Code with the plugins installed so that you get syntax highlighting and auto completion and these types of things. Google Cloud Platform really should have been in there with Azure and AWS. This is so DigitalOcean you have on the lightweight end where it's simple, easy to use, very beginner friendly. Then you've got your AWS, Azure, and GCP are the heavyweight, clunky, expensive, hard to use type platforms that I don't know why people use them when you've got other better options, but they do, I guess, because they're global and all that. But it's a platform with servers and services and functionless and serverless and codeless and all of the less things. They're all there in GCP. Then you've got switching gears entirely. Now we've got dry. Dry is a very common paradigm. It stands for don't repeat yourself. So if you were on the other night when we were going through bash code and refactoring and we were taking similar pieces and splitting them out into functions and replacing maybe 3 or 4 lines of similar code with a function, that was don't repeat yourself. We're trying to find out where is the stuff that is likely to, if we were to change, the reason is this: if we were to change code in one place, it's likely that we'd need to change code in the other places. So if I changed the way, for example, that I was getting the dates, and I was getting the dates in 3 different places, I'd need to change it in all 3 places. So don't repeat yourself. The idea, or dry code, the idea is that you clean up the code so that you put common code in functions, and then if you need to make a change or just for better readability, you've got that in one place. Now, the opposite of that, which actually was supposed to be right here, let me go ahead and put that down, is wet. And wet, well, it's not really the opposite. It's just, yeah, but. Because don't repeat yourself can be a very bad paradigm. It's not something that you want to start with. First, you want to write your code, and you want to figure out what your code's supposed to be like and really understand how the code will express itself, meaning what types of options might you have and what kind of hangups do you run into if you don't have any options or parameters that you can pass in. So wet stands for write everything twice. And what this means is you want to write out the full functionality of a segment of code twice before you decide to dry it up. Because if not, what you'll end up with is very, very tiny functions that are all calling each other. You kind of have this really nasty waterfall of 1 or 2 line functions. Oh, excuse me. Sorry about that. So you get these 1 or 2 line functions that don't really provide a lot of value or give you a lot of information about what is supposed to be going on, and they're chained together, and it makes your code harder to read, and it also makes it so that when you want to change one aspect of your code, say that you realize you have a shape function and the shapes you start out with square, and that can only take 1 parameter, which is the length of a side. Well, all sides are the same in a square. Let's say later you decide you want your shape function to also be able to draw rectangles. Well, then it would need 2 parameters, the shapes of the length and then the the length of the length of the length and the length of the width, or the length of the height and the length of the width, depending on how you look at it, right? And so if you had your code very dry and all in these little tiny functions, when you go to make a change that's relatively simple, like adding another parameter to a function, you have to go through a whole string of functions and maybe update 3 or 5 of them, and then you're no better off than you were before because you're having to make just as many changes. And then aha is kind of it's really, I guess it's the same thing as wet, or maybe it's the looser, there's dry and there's wet and then there's aha, and aha is just the more middle ground kind of. It's avoid hasty abstractions, meaning yes, we want to write things to make sure that we understand what they are. Yes, we want to not repeat ourselves and have code that is clunky and loose, but it's all about temperance. It's all about just taking some time, understanding what the code is, and then doing the right thing for that situation. Sometimes we want duplicate code, sometimes we don't. And that's what AHA stands for. Then we have TDD, BDD, DDD. Test-driven development, that's what TDD is. And this is the same thing that we talked about before. I just moved this one down here, the red-green refactor. So test-driven development means that first it's good in the cases where you know what your program is supposed to be and supposed to do ahead of time. So when it's not super exploratory. If you already have good requirements for the program is supposed to behave like this, and usually you can define this in some way. You know at least some things that your program is going to do, and you have to know that to some degree before you start. But you don't know all the possible ways your program might be used at the start. Like I just gave with the example of the square and the triangle. You might think that you just need to draw squares, and it turns out you also need to draw rectangles, or other shapes too. You could make a function that draws shapes with any number of sides, with any length of side, whatever. But the point is, with the red-green refactor, you start with a test for the code. So you create a test that calls the function or the behavior of the code, and it should fail. And this is to test that the test works. So red is actually testing that the test works. If you write a test and it passes when you haven't written the code, then the test is broken too. So the red part is you write a test that's going to fail, saying, I'm going to call the get square function and I should get back a shape object that has 4 sides, and every of the 4 sides should be 4 units of length long. So you're going to call get square 4, and that's what it should hand back. So that would be your test. And when you run that test, it should fail because it's not going to get anything. It should just say, there is no get square function, I give up. Or if you put an empty get square function, it's going to get back nothing, and it's going to say nothing is not a shape object with so many sides and such. And then the green part is when you implement your get square function so that it returns, maybe it's an array of lengths, or maybe it's an object that describes a square in some way. And then refactor is after you write the test and the test fails, then you write the code and the test passes. Then you just take a look at the test and the code and decide, are there some things here that I could clean up or make simpler? And it goes back to the idea of the dry, wet, aha model. That's what refactor is. Refactor is when you kind of pick one or all of these methodologies and apply it to your code. That's called refactoring. So then we've got BDD. BDD is just a behavioral driven development. It's just a sugarcoating of test-driven development. Now, someone's going to crucify me for that and tell me how I'm all wrong, but that's the truth of the matter. Is when you look at TDD versus BDD, the difference is that the test-driven development will have more technical sounding names of the tests, like it might be get square, whereas the BDD might have something that feels more like English and sounds more touchy-feely, like the user experiences the greatness of a wonderful square. I'm overdoing it a bit, but behavior-driven development just kind of uses different language characteristics to describe a test. And then we have DDD, which is documentation driven development. There's a few different words for this: document driven development, design driven development. I think there's another one, but they're all DDD, and this one is less formalized than TDD or BDD. And this is not about testing at all. This is about when you start your project. We talked about paper prototyping. This is essentially, well, it's not quite paper prototyping, but it's along that vein. Document-driven development is when you write a README first and you detail how someone should be expected to be able to use your program. So, for example, we write out this program has a function that's a get square function, and it will accept a number for a length of side, and it will return an array. So it's kind of like the TDD in the sense of you're defining your requirements, but this is more on the side of the requirements than the test of the requirements. And so this is just a really good way when you're thinking about, okay, I'm going to start writing code. Maybe don't write the code right away or even write the test right away, but just make sure that the requirements are clear, that you can articulate in English and with some examples. And I would love to show you this. Well, we'll go into it later. But essentially, I do this all the time where I think, okay, I need a function that's going to manipulate dates. And I write out what's called the function signature, which is the name of the function and then what the function will receive and then what the function will return. And I just kind of write it out and I document what the function does, like I described just a minute ago. All right, and then I think the last thing we're going to go into tonight is YAGNI, because I think that kind of concludes this very similar grouping of alphabet soup here. YAGNI is you ain't gonna need it. So for those of you that are not American by birth or as your first language, you will not need it. You ain't gonna need it. Ain't is it's kind of like are not, is not. It's a redneck. It's a dialect word. So and yeah is. Yeah, so you ain't gonna need it just means don't worry about things that you don't know that you need is what it means. And so a lot of times there's actually a great XKCD for this. I'm gonna bring it up just one second here. XKCD salt algorithm, salt passing algorithm. Let's see, salt passing. The general problem is the name of the XKCD 974. So let me bring over this here. So this is what YAGNI is trying to address. Let's just make this as wide as we need to make it. There we go. That's good. So the general problem. Let's make it even bigger. There we go. Hey, can you pass the salt? And there's two people sitting at a table, and the person's just waiting there for the salt. I said, I know. I'm developing a system to pass you arbitrary condiments. But it's been 20 minutes. It'll save time in the long run. So this is the you ain't gonna need it principle. Sometimes we start out with, okay, I need a function that can construct squares or tell me the area of a square or do something with squares. And then we start thinking, well, maybe our program is going to become really popular and people are going to want to use our program to generate rectangles. And actually, maybe our program is going to become uber popular and rectangles and squares just aren't going to cut it. We're going to need triangles and circles. And so you start thinking in your head about all the ways that this code could apply and how great it could be. And instead of actually writing the code to accomplish the initial task and getting one thing done, you get stuck in this loop. And this happens to me. This happens to every developer. I don't know anybody. Well, I know one person I don't think this happens to. But he's a genius of the highest level. But most of us, we struggle with this problem where we sometimes go to generalize something or add extra features that we think maybe we will need, but they're not necessary at the moment. And if you just focus on the things that you know you need, get that working well, you don't have to worry. And if it's written decently well, you don't have to, paint yourself into a corner. But if it's written decently well, then you will be able to go back and either copy your get square function or modify it to be a get rectangle type of function. So don't worry too much about those things, especially when you get into larger differences. Like, I want to get shape function. Well, circles are very different from squares in many ways. They don't have any lengths of a side. The area is calculated very differently. So squares and rectangles end up being similar, but triangles are quite a bit different and circles are quite a bit different. And some of the polygon shapes you could write a get generic polygon function for, but that doesn't mean that that would actually be the function that you generally want to use, because squares and rectangles are more common than pentagons and many other types of shapes, septagons, etc. So it's actually better to have a little bit of excess code that is more efficient and effective and easy to understand than it is to write code that's too generic. And this is just a general problem in programming, is finding the balance for the particular program that you're working on that day, not in general, because that would also be a moot point, but finding the balance between how many layers of functions, how many variables, how many items that can be passed in to modify something versus how static can you make it. Finding that balance is always hard, and it's different for every program. There is no right answer, and there are multiple correct solutions to these type of things. Anyway, that's all that I got for you tonight. So I hope that this was helpful. If it was, go ahead, give it a thumbs up. If you want to subscribe, the live channel is my personal channel, CoolAge86. That's in the description. The Beyond Code channel is also in the description. And basically the difference is I do a lot of stuff on my personal channel, and I'm trying to move over to the Beyond Code channel for this type of stuff. But since my personal channel is where I have my following right now, I kind of want to leverage that. So that's kind of the history behind that one. Anyway, that's beside the point. You have absolutely a wonderful evening. I saw that there was already a thumbs up on here, so thank you very much for that. You all have the best night ever. And oh, one last thing. If you have any questions or comments, please hit me up on Twitter with questions @_beyondcode. And if you have any comments, leave them in the comments. I'd love to know what you'd like to learn more about. If I introduced extra words that were also confusing, because sometimes when we define something, we spit out more words. I think I kept this in mostly simple language, but if there's anything I didn't explain well and you want to understand it better, leave that in the comments, any of that type of stuff. And yeah, you have the best night ever. Adios.